Hi, so this video is a technical demonstration of a real-time strategy movement system. So it all starts in the command maker class, which reads user input. So when the user hits right click and has some unit selected, the system will send a ray from the camera uh, onto the terrain, and the program will sample a position on the nav mesh. This will make a new command and create a new squad and create the command inside the command manager. So the squad starts off empty, and what a squad is basically a list of units that also contains the command and the goal node. Then we create the command in the command manager. We save the units that are performing that command, update the log, and then we command the units. So we can either shift command the units, which will add the commands to the queue, or simply command the units, which will clear the queue and make the units instantly receive the command. So as soon as the command is received by the units, we will do command manager on command received. Which will remove the unit from the old squad and add it to the current squad. By adding it to a squad, we also create entries in the group manager. So, what is a group? A group is a set of units that is nearby. In contrary to the squad, which is all the units performing the command. So now that the unit is managed by the group manager, the group manager on its update method will iterate every squad and find what group the units in the squad uh, belong in. This is done with the calculate groups method. And we pick the groups by finding the unit's neighbors. So the search space here is already largely reduced because we only iterate the units in the squad. But I also use a method uh, of a solved unit map where if the operation between two units was already done, uh, that doesn't do it again, uh, meaning that there is no duplicate calculations between the neighbors. And then a number of different scenarios might happen. So um, if this is the first unit, then it will be tested with every other unit. Otherwise, it will only test with units which are not in the solution map. And the groups can either if the neighbor has stopped being neighbors with this unit, then it will remove the units from their neighbor map. And if they are units, then we run the find group command. And here, the units might either join each other's group, create a new group if neither of them have a group, or if both of them have groups, but they are different groups, then the groups will combine as all the units will by then be close to each other. So now that the unit knows which group it is in, it will run the find path command. Which will send a line of sight to the goal. If it can see the goal, then there is no need to find the path, or otherwise it will calculate the path using the navmesh method. So now that the unit has a path, we can go into the unit's update. Which checks if the unit belongs to a group, and if it does, it will check what is the next node in the path. If the next node is not visible, i.e. the path is invalid, then the unit will find a new path. And otherwise, it will start to perform its flocking behaviors. So, first we're gonna find seek, which is the behavior that leads the unit towards the target node. And then it will run some flocking algorithms, i.e. cohesion, separation, alignment. So it will iterate each of its neighbors. It will find the um, cohesion, direction, and power. This force brings the agents closer to their neighbors. Then we will calculate the separation, which keeps the units a certain distance away from its neighbors. And then we calculate alignment, which brings the agent velocities to be closer to each other. We weigh these forces. We truncate the resulting velocity to the maximum speed that the unit can have. We will also find some obstacle avoidance. which will send a raycast in the direction of velocity, and if it hits an obstacle, then it will output a direction and power that should bring the that should lead the unit away from the obstacle. We're gonna truncate again. If we have the arrive behavior enabled, then we will clamp the magnitude of the velocity to the distance to goal, making the unit slow down when it's close to the goal. So then we rotate the unit, move the nav mesh agent along the um, velocity, and then we check if the unit has crossed its waypoint. So first we will check if the group is within goal distance, i.e. If the unit is ready to finish the command completely. And what the goal distance is whenever a unit completes the command, the goal distance will grow based on the agent radius, and the goal distance is a circle around the average position of the units which have finished the command. So if the unit is within that circle, then and if the unit's velocity is also under the goal reach speed, then we will consider the command as finished. And the reason this works is because all of the forces that act on the unit cancel each other out around the goal point. If we're not finishing the if we're not completing the command, then instead where are we? Here. Okay. We will find the dot between the direction to the next waypoint and to the waypoint after it. If we are very close to the waypoint, then the waypoint will be marked as completed. Or if the dot product is less than 0, so the waypoint is behind the unit, and the unit has line of sight to the next waypoint, then it will be also marked as completed. So now we know when the waypoint is completed. We're gonna pop the waypoint off the queue. If there is more waypoints after this one, then the unit will start seeking towards the next waypoint. And if this is the last waypoint, then we will call complete command. So if we have another command available in the queue, then we will immediately receive it, and we will also call on command completed. So this will flag the command as completed for that unit, so that when a new one is received, uh, it will remove the unit from all the previous instances of the squad and the command map. Until the next command is received, the unit stays in the squad, so that all the group behaviors uh, remain as if the unit was still part of the squad. Let's just quickly show this in action. So make command, make the goal distance grow, complete the command. All of these units are still part of the same squad until a new command is received. And that would be all for this technical demonstration. Thank you.